The following is a tutorial on converting molecules or atoms to moles. Okay, so this is going to be the opposite process of the last video. Okay, as always, we start by writing down the given information. Okay, notice I cannot abbreviate molecules. Molecules and mole are not the same thing. Okay, so we need to get used to writing that out. It's going to keep you from making mistakes later on as the conversions get a little bit more complicated. So we saw that we're looking for moles, okay, in 3.31 times 10 to the 24th molecules of CO2, which is carbon dioxide. All right, so I have my given. Okay, on the top of this step, I have molecules of carbon dioxide, so I know that I'm going to have molecules of carbon dioxide on the bottom, okay, and it is 6.02 times 10 to the 23 molecules in 1 mole. Okay, if you ever have anything other than 6.02 times 10 to the 23 next to molecules or atoms, you're doing it wrong. Okay, so make sure you look at the conversion factors that I give you. Okay, so let's pretend we do not know how to do scientific notation on our calculator. So the easiest thing to do is to be able to get rid of these exponents. Okay, if they are both matching, so if these are both 10 to the 23, then they can just cancel out. 10 to the 23 divided by 10 to the 23, it's going to be 10 to the 0. Okay, so if I want to change this exponent to be 23, okay, and it doesn't matter which exponent you change, as long as you move the decimal the correct way. So basically, I made this number one number smaller, so this is going to get one decimal place larger. Okay, so I made this one decimal place smaller. I went from 24 to 23, which is 1. Then I moved this one place larger. So I went from 3.31 to 33.1. Okay, and we did that so that we can cross out our exponents. Okay, and we put molecules on the bottom here so that we can cross out molecules. Now this makes the math really easy. So now we have 33.1 times 1 mole divided by 6.02. So we changed this exponent to 23, which changed 3.31 to 33.1. Okay, we got rid of our units, and I rewrote this down here just so that it's a little bit easier to see. So we have 33.1 times 1 divided by 6.02. Keep in mind, we multiply the numbers on the top, we divide by the numbers on the bottom. Sorry, I forgot to put my phone on silent. Okay, so 33.1 divided by 6.02, and I get 5.4983. Okay, I'll stop there. Okay, so we're going to look back at our given information to determine how many significant figures we're going to use. So up here I've got 3 sig figs, so my answer can only have 3 sig figs. Okay, so I'm looking at the 4th number, okay, 3 significant figures, the 4th number determines how we round up or down. So this 8 rounds 9 up to 10, which rounds 4 up to 5. Okay, so because the 3rd number was a 9, and this 8 rounded 9 up to 10, that's going to add 1 more to this one. So it becomes 5.50. Okay, and that should make sense. 5.4983 rounds to 5.50. Okay, and then your units are moles of carbon dioxide. Okay, so whichever unit is left up here on the top, that is the unit that you have. Okay, and in the question it was asking for how many moles, so you are done. Okay, in the future we're going to have 2-step conversions here. Okay, Next problem. How many moles are in 1.50 times 10 to the 20 grams of carbon? Oops, sorry, atoms of carbon. Misspoke. 1.50 times 10 to the 20 atoms of carbon. Okay. So we are going to multiply that by the conversion factor, which we read as a fraction. I have atoms of carbon on the top, so I know that I need atoms of carbon on the bottom. The number of atoms in 1 mole is 6.02 times 10 to the 23. Okay, and that's the number of atoms in 1 mole. Okay, remember, if you have 1 mole of anything, you have 6.02 times 10 to the 23. Just like if you have 1 dozen of anything, you have 12, and so on. Okay, so we have some ugly exponents to work with again. I have times 10 to the 23 here, and I have times 10 to the 20 up here. So I'm going to change 20 to 23. Okay, so you have to ask yourself, what's the difference between these two numbers? 23 minus 20 is 3. So I'm going to be moving the decimal place 3 places. Now, I made this number larger, so that means in this case, this number is going to get smaller. In the last example, we made the exponent smaller, so our number got larger. Okay, now we're moving it the opposite direction. So we're going to move the decimal place back 1, 2, 3. Okay, I made this number 3 numbers larger, so the decimal place gets moved back. So we went from 1.50 to now 0.0015. Okay, it became a smaller number. We did that so that we can cross out these exponents, and we crossed out atoms. So now I'm going to rewrite this down here. We have 0.00150 times 1 mole over 6.02. 0.00150 divided by 6.02. Okay. And I got 0.000249169. Okay, I'm just going to write out the whole number. Okay, so my given information had 3 sig figs, so my answer can only have 3 sig figs. That means that I'm going to look at the 4th non-zero number over here. Okay, so remember the numbers start right here. None of these zeros are significant. Okay, please see the other videos posted in Unit 1 if you're still having a little bit of trouble with that. Okay, so here, 3 sig figs, I'm looking at the 4th number, which is a 1. So that means that this is just going to round down to 0.000249. Okay, and when we're rounding numbers to the correct number of significant figures, you need to ask yourself, are these the same number? Okay, 0.000249169 rounds to 0.000249. Okay, that's pretty much the same number. Okay, if we're dealing with numbers after the decimal place, okay, to the right of the decimal, we can just drop off the numbers and it's pretty much the same number. In the example up here, we were able to do the same thing. I think it would be a little bit more convenient to write this in scientific notation just because it's such a small number. So this would be 2.49 times 10 to the negative 4. 1, 2, 3, 4 is the distance I have to move the decimal. Okay, and the exponent is negative because the original number was less than 1. Okay, and then my units on that are moles of carbon.